Good morning, all. You are welcome to Pharmaceutical Calculations BD 253 Tutorials with Pharmaceutical the School Boy. Today, we'll start our revision for the pharmaceutical calculations. In your WhatsApp group, I sent about 1,100 questions, 100 questions per topic. The 11 topics we will cover in pharmaceutical calculations. So each topic has 100 questions, 100 subjective questions. You just solve and fill in the space with your answer. That's all. Then I also sent you question distributions, how each of the topics will contribute questions for the final exam. The exam will be 100 questions, and the number of questions expected in each of the topics are there. So that means for numbers and numerals, for example, now 10 questions will come out from numbers and numerals. Now, because of time, this revision will be a kind of tutorial cum revision because there's no time. So we meet just once a week. So it will be question oriented. So what I want you to do is this: you have done this, you've read this before, read it again. So it's no longer anything for you. We have covered all the topics. So all you need to do is this: go through the questions. That 1,100 questions, solve them, use them for practice. Then from these 1,100 questions, let's assume now you in numbers and numerals. You solve. You find out that there are some questions you find it difficult to understand or you couldn't solve. The idea is that even you are up to the required number. The idea is this: those that in that particular class will contribute in numbers and numerals. Now you bring 10 questions from there that you choose from. Those ones you find you don't understand, or those you find it difficult to solve. Choose from them. Now that you are 2, you can contribute 5 from the ones you could not solve. Then I will use those ones as point of contact for our revision for today. So if you are done, if we say half time, we move to the next topic. You check the number of questions you get from that topic and choose from what you have solved. So this is what we're doing until we finish the 11 topics. So this will serve as a revision at the same time, a review at the same time, teaching you some things you find you could not grab during the main lecture. I don't know if it's clear. So because he was the only person there here when we started, he started choosing those questions. He chose 100, 8, 9, 90, 4. And 6, 1, 2, 3, 4, 5. Because you came in, he now allowed you to contribute your own, because you must have you need to solve it, or you must have solved it. You must have 1 or 2 issues from that. Am I completing? You give 5, just 5 questions. From here to here, you may choose just from what you wrote. Now you have said almost 20 questions. You see clear? So just hit the particular question. Then if when you are done, I'll now come out and pick each of them, will solve it. Each of them will solve it. This is how we're doing. Once it's 11 o'clock, we'll stop. 1 o'clock, we'll stop. Next week, we'll continue. This is what we do until you actually we end when? December. That means you resume when? January. So by December, even that, I believe if we are consistent, if you don't miss classes, we have up to 8 contacts. We'll cover these things. And if you cover these things, I believe you will do well, because I will use that opportunity to teach you some things you could not, or maybe remind the things you have forgotten, or the things you could not grab. And this is available for you to ask questions. Okay? You can ask questions. It's not just about solving this question. It's just a point of contact. As we are solving, you cannot ask questions, things you don't understand in that particular topic, because the question would have exposed a lot of things in the topic. If you want to achieve something from it, if he choose, let's assume he chose number 100, and you've seen the structure of 100. You know, question structure differ. Don't go and choose another question that have the same structure with what? 100. Look for that question that have a different structure. That will give us an avenue to do what? Explain things in that area. Am I communicating? Maybe you chose 100. You go and start picking the same thing, have the same pattern, the same structure. No, you are not helping yourself. Am I communicating? So that's what I want us to do today. Because there are some questions that one particular pattern, one particular step, you can solve about up to 5 questions. Hope you know. That's how calculation looks like. So choose questions that are not related by what? Pattern, so that you'll be able to do what? Cover a lot of things within this short period of time. So please, I hope this thing you choose, they don't have this exactly the same pattern. All right. So you cannot come up and choose your own. You just take your time, go through it first before you choose. Don't just come and choose. First of all, look at the ones he chose. Then look for others that have different what? Listed from their hair. Okay. Okay, as you can see on the board, the first question says question 100. Question 100. So question number 100 says the cornerstone. This is not complete. How do you do it? It's scattered. Why is it scattered in your own phone? See, it stops here. Okay. Okay, I've seen. The question says, the cornerstone of a hospital shows the dates when the hospital was built as MCMLXV. When was the hospital built? We have MC, MLX what? V. This is just simple. You wanted to convert this to what? From Roman to what? Arabic what? Numerals. Simple. So let's go. M is what? 1,000. M is what? 1,000, right? C is what? 100, right? M again is what? 1,000, right? L is what? 50. X is what? 10. V is what? 5. V is what? 5. The cornerstone was to show that the date when the hospital was built is this. When was the hospital built? Okay, let's go. So if this is 1,000, this is 100, right? Yes, sir. And this is what? 1,000. This is what? 50. Then this is what? 10 and 5. Okay. What do you think here? It should be you. From your knowledge of what is it called? Roman numeral. Just say what you think. Don't matter whether it's correct or not. Just say what you think.
I think about the answer.
The answer, yeah. What do you think it should be? In Arabic numeral. Okay. MCM. 2 what? 2,000 what?
100.
100 and what? This is the year, right? When was it? So year 2000, something that passed. 2005 is still coming. Okay, let me help you. Look up. Remember our rules of numerals. This one is separate. This is what? 1,000. Look at this place. C came before this M. On a normal, C is 100. M is what? So the value of Cm is what? 1000 minus what? 100. Can you remember? So this will give us what? 900. Remember, here is what? 1000, right? Then here we have Lx V, right? Now L is what? 50, right? So 50, this 50 plus 10 plus 5 is what? 65. So add up. 1000 plus 900 is what? Plus 65. 965. Are you following? So it's 109 what? 65. So when was the hospital built? 1965. You know what a cornerstone is? What's a cornerstone?
Something like our school and cornerstone.
Okay. See what by this picture, see what they mean by cornerstone. If you go downstairs now, look at before you climb that stair. Just here now, just go out. This place they have something like slab, marble on the wall, and they wrote this building was dedicated so date under the leadership of Reverend Mother General, blah blah, all those things. Now they write the year. So that's what they are saying, that in the cornerstone of that hospital they wrote something like that the hospital was built in so year, but it was written in what? A Roman numeral. They don't want us to tell them what dates. I mean, just simply move it to what? Arabic. So you can be clear. It was built in 1965. Okay, 1965. If you like, you can even write it as word. It's even better said. 1965. Is it clear? Good. If you have any question here, let's trash it. If there's no question, let's move to the next. Number 8. Any question? All right, let's go to number 8. Number 8 says there's a list of numbers here. Let me list them. The first one is 3i, 2 plus 4i, 9, 2, root 7, pi, 22 over 7, 1 over 8, 1 over 3, 0, minus 4, 7. Let me leave it permanently on this board because some question may still come out from there. Number 8 says, which one of these is or are irrational numbers? That's what number 8 says. Which one of these is or are what? So this question wants you, if you want to list, you must list all the irrational numbers here. That's the meaning. Don't just pick only one and stop. You must list all the irrational numbers in this what? List of numbers. That is how to get your mark. If you miss any one, you fail it. Is it clear? So now, what are irrational what? Numbers. What are what? Irrational what? Numbers. From the class, when I thought to put this in class, I told you that a number is what? Irrational if it cannot be expressed as a fraction. Okay? It cannot be expressed as what? A fraction. The number is what? Irrational. That's why I told you that you may see a number that have the decimal point. A number may be in the decimal form. Decimal point. It may have decimal point, but it may not be it may be irrational. It may not be a rational number, okay? So remember, a rational number can be a rational number is a number that can be expressed in this form, right? Remember, a over b, where a and b are what? Integers. And a can be 0, but b cannot be what? 0. Now, an irrational number cannot be expressed like this. It's not possible. Example, 2 is a rational number. 2 can be expressed as this. This is certain as 2 over what? 2 of us. Good. Now, something like pi is an irrational number. You can't express pi, even though the value of pi is 3.14 blah blah blah. But you cannot express pi in this form. It's not possible. You cannot achieve that. So pi is an what? Irrational number. Now, another number that is, you see roots, you see sorts of our what? Irrational what? Numbers. Sorts are what? Irrational number, because you cannot express them out. Hope you know that you see not every number under the root sign is a sort. Hope you know. Perfect squares and they're not sorts. Hope you know. Perfect square like root 64. Root 64 is not a sort because it has a root. True of us. Root 64 is what? Is what? Root 64 is what? It's 8 now. It's not 8. 8 times 8 is 64. It's not. So because of that now, root 64 is not a sort, even though it has that sign. So don't think that a number becomes a sort when it has that square root sign. No. It's when that number doesn't have a root, a particular root as a whole number. I'm not complicating. Once it doesn't have a root as a whole number, the number is a sort, and it do not form a fraction. It do not form a rational number. It's not a rational number. Now, the fastest way to know if a number is rational or what? Irrational is this. If you are given a number, try to convert it to be in decimal form. Like if you are given root 2, convert that root 2 to be in decimal form. If you are given pi, convert the pi, find the value of pi to be in decimal form. Then you check that decimal form. If the number is not recurring, remember I talked about recurring decimals.
Yes, sir.
And not recurring what? Decimals. If decimal you form from it is not recurring, it's scattered, it has no pattern. Recurring means that it has a pattern. It will repeat itself after some time. If it doesn't repeat itself after some time, if it doesn't repeat itself after some time, that number is an irrational number. But for a rational number forms a recurring decimal. After some time, it repeats itself. It may be continuous like 0.3333. It may be that it will move for about 2 or 3 digits and we'll go back again and continue from the beginning. Then a number that form a decimal that is in this either of these two forms is a rational word number. Let me give an example. Let me put pi here and put and write root 2. Root 2, root 3, root 5, root 7, they are not perfect square, you know. They can't give you a square root in a whole number. They will form sort. They are sorts. So root 2 is a sort. Let's also add root 3. Now let me add 22 over 7 and 1 over 5. Then find the decimal form of these whole numbers. Pi, what is the value of pi? List all the numbers there. What is the value of pi? 3 point what? 14 15 92 65 35 89 79 32. Let's stop here. Root 2. Oh yeah. Root 2. 1.4. 14 21 35 62 37
30
95
95
04.
04.
Let's stop here. Root 3 income. 1.7. 32 05 08 07 56 88 77 29. Let's see the rest. What of 22 over 7? 3.1. I'm coming. 3.1. 42 85 71 43. Huh? No, check in your phone. I want to fill this thing. Use your phone. 22 over 7.
31 42 85 71 42.
Wait. 42. 85 71 42 85 71 42. Now let's look at 1 over 5. 0.5. Sorry, I didn't mention something. Decimal can be terminating decimal or recurring. So both terminating a number. If you move a number to decimal form and it has either terminating decimal or recurring decimal, the number is a rational number. But irrational number has no terminating, and it is not terminating. It's also not recurring. Now let's look at these numbers. This pi is what? Look at pi. Pi is 3.1415 90 63 65 35. Is it a pattern? Is it a pattern? It's scattered, right? So pi is an irrational number. Look at root 2. Look at root 2. Look at root 2. Look up, please. Root 2 is 1.4142135 60. Is it a pattern? It's scattered. So root 2 is an irrational number. Look at root 3. 1.7320508075. Is it a pattern? That means root 3 is an irrational number. See 2 over 7. 3.1428571428571428571428. Is it a pattern?
Yes,
it's recurring. 22 over 7 is a rational number. Okay, check 1 over 3. Divide it is what? 0.333, right? True or false?
Yes.
Does it have a pattern?
Yes.
So 1 over 3 is a rational number. 0.5 is 1 over 5 is 0.2. Sorry, not 0.5. 0.2 is a rational number. True or false? But it has a terminating decimal. It's a rational number. But 2 over 7 is a rational. But root 3, root 2, pi, they are not what? They are irrational numbers. Have you now seen why pi is not 22 over 7?
Yes, sir.
That is something. See what happened in your secondary school. They just wanted to look for something that will give approximate value, because you know that if you stop here, if you stop here, see it here. If you approximate here now, you have 3.142, and if you approximate here now, you have almost something. That's why they tell you assume pi to be what? 22 or 7. But they're not what? The same thing. Pi is irrational. 22 or 7 is what? Irrational. So with this now, what do you think is the answer? For this explanation, what do you think is the answer to this question? The irrational numbers then.
Irrational numbers are 22 over 7.
Irrational numbers.
So sorry, irrational.
Rational numbers.
I mean irrational numbers.
Is irrational.
Is it only pi?
No.
What else?
2.
2.
We are 7.
Root 7.
We are 7.
Good. Root 7 and pi are what? irrational numbers. Okay? In this question, root 7 and pi are what? Open your phone again. Are irrational what? Numbers. Root 7 and pi are irrational numbers. Is it clear? Should I clean? Right. Let's go to the next question. So root 7 and pi are irrational numbers. Let's look at question 9. Question 9 says, this on the same list of numbers. Question 9 says continuous rational numbers. There are two things here. One is what? Continuous. And one is what? Rational number. This is simple. Just look at the option. Look at the numbers. List all the numbers that are continuous at the same time. Rational. Simple. You know a rational. You know what I mean by continuous. The number has no end.
Yes.
Continuous. True of us. Now look for which of them is continuous and which of them is discrete. Now look at this now. 1/2 is equal to 0.5. Is it continuous?
No, it's continuous.
Good. Now with this, now let's look at this question. Which, first of all, you should know, before you can answer this question, you should know, see what you do. First, look at all the continuous number there. Then from them, you find out the ones that are what? No, look for all the continuous number here. From them, from all the continuous number first, among them, you find among them the ones that are what? Rational. Simple. Or you look for rational numbers first. Among them, you pick the one that are what? Continuous. Simple. So let's look at the one that are rational and continuous at the same time. Is 9 a rational number? 9. Can't 9 be expressed as 9 like this? So it's a rational number. True of us. 9, these ones are just complex and what? Imaginary number, right? 3i is an imaginary number. 2 plus 4i is what? Complex what? Number. Now let's go. So 9 is a rational number, but it's not continuous. True of us. 2, but it's not what? Continuous. Root 7 is irrational. So it cannot be business with what we are doing. Pi is what? Is irrational. It cannot be business with what we are doing. What about 22/7?
It's rational.
Is it continuous?
Yes.
So you pick what? 22/7. You move to the next one. What about 1/8? Is it rational?
Yes.
Is it continuous or terminating? So is it among?
No.
What about 1/3?
Rational.
Is it rational? Is it continuous?
Yes. No.
Yes.
1/3.
Yes.
It's continuous.
So 1/3. Next one is what?
0.
0. Is 0 a rational number?
No.
Yes. A can be 0. Remember, a rational number, a number that can be expressed as A over what? B. Where A and B are integers. Is 0 not an integer? So that's what I say. So, but it's not continuous, right?
Yes, sir.
-4 encore, is it a rational number? It is. Can't you have 10 like this? That's what I say. This one, but it's not continuous, right?
Yes.
Is 7 a rational number?
Yes.
Is 7 a rational number?
Yes, sir.
You see, you don't really understand what you mean by rational number. I think I've explained it that it can be, can't 7 be expressed as 7/1? No, my focus on is it rational, but it's not continuous. You know, you take it step by step so you don't make a mistake. Take it step by step. You see how I single it out now. You must go through the question and ask yourself this question before you can get the correct answer. If not, you make a mistake. So from all this is now, the only continuous and rational number here are what? 2/7 and what? 1/3. So this is the answer. Is it clear?
Yes, sir.
Any question there? Then question 90. Open. Question 90 says, this is number 2011, question 90 says 2011. And we are converting this number, this 2011 is in what? Arabic numeral, right? So we want to convert it to what? Roman numeral. So see what you do. Remember that this is separate the place values. You have, this is 2000, right? Plus what? 11, right? True of us. And 2000 will give you 1000 plus what? 1000, right? This will give you what? 10 plus what? 1. True of us. I have broken it down to the building blocks. True of us. To a smaller unit, so I can now build it up again. 1000 is what? 1000 is what? 10 is what? X. I. So the answer is what? X what? I. True of us? True of us? Good. So if you are done, let's go to question 4. Question 4 says, from this same list of numbers, from this same list of numbers again, the question says, list the words. Number 4 says, discrete what? Numbers. Discrete what? Discrete numbers are not continuous, right? So let's start again. This one is what? Imaginary. So this one is what? Complex. Is 9 a discrete number? Is 9 a discrete number? You want to answer that question? Is 9 continuous?
9, yes, continuous.
9.
No, sir. No.
So 9 is what? Are you sure?
Yeah.
You are doing as if you are guessing.
No, sir.
Don't guess. So 9 is what? Discrete number. Please take this in. I don't think school will give people any other opportunity again. If you have issue again in the discourse, I know what it took me to ensure that that this thing hold. So please take whatever we are doing very seriously. If you don't understand, ask questions. That is meant to not keep quiet and make me believe that you understand, you are following. Please, let my coming every Saturday not be a waste. Because if it happens, school will not listen to any of you again. So please, as we are here now, anything you don't understand, ask question. I will explain. If we do 1 p.m., we'll go. Next Saturday, we'll continue from where we stopped. We have time to cover this thing. Ask questions. If you're able to cover this question, this number of questions per topic, you would have learned a lot. So take it seriously. Please don't keep quiet, please. I beg you. So here is what? It's 9. So we have agreed that 9 is a discrete number, right? What of 2?
Yes.
2 is a discrete number, right? What of root 7? It's not, right? It's continuous, right? Even though it's irrational. True or false? Pi income is continuous, right? 3.14, so it's not. 2.7 income. This one income. Is it? Did it stop?
Yes.
What else? What about 3 income? Divide it now. Continuous. You don't think it. Do you punch your calculator and see where it will lead you? Don't think about it. Just do it. It continuous, right? Good. So it's not a discrete number. What of 0? Good. Minus 4.
It's not.
Is minus 4 a continuous number?
Yes, sir. Yes.
Continuous number?
No.
Is it what?
It's
What type of number?
But na this week to go then can video from 0 to
No, that's the problem. A number that is definite stops at a point. You can distinguish this is where it stops.
okay.
Half is half, 0.5 is 0.5.
Okay.
1 is 1. But 1.1333, it can never stop. True of us? It cannot stop. You have to stop. You must approximate it before you can stop. It's not true.
It's true.
So minus 4 is what? 7 uncle. So the natural numbers say are what? 9, 2, 0 and what? 7. So these are the what? Natural numbers. Any question there? Any question?
No, sir.
So I will stop here today. Please, I want you to go revise what we have done and solve more questions under this number of numerals. Keep reading. I've sent you the 1001 question. Keep solving. Because it's when you solve them, that's when you see questions you can do what come up with. Okay? Solve them very well and make sure you understand every question there. Please inform others that are taking excuses up and down. We have started. Even though I'm recording this now, I'll post the link in the group. What if I edit it? I'll post the group the link in the group. Those that want to listen will listen. But this is serious. They should not take these classes. Okay? All right. Thank you very much. God bless you.